So thank you everybody for joining, and thank you and welcome to the Geothermal AI Innovation Contest. I am Pushpesh Sharma. I am the programs chair for the data analytics study, data science and engineering analytic technical section, and I professionally work for Aspen Tech as a senior product manager. So before we start, I wanted to just go through some housekeeping item. Please keep your microphones and camera off. And after our presenters are done, we'll invite everybody to ask questions, so that at that point you can always unmute yourself and ask your questions. Feel free to post your questions in the chat. We have a lot of committee members online who can help answer your questions. And as a reminder, I think you probably are already aware of it, but we have a Slack channel established for this competition. So for live Q&A and for some updates, please join the Slack channel, and we'll keep posting some updates there. And just one final reminder, there is still time to register for the event. So please, after the kickoff, just talk to your friends and professional colleagues, and just make sure we want to make sure that a lot of people join this event and we can have a good collaboration going on. With this, I'm going to hand it over to Danny, and he's going to go over some introduction to the event. Thank you, Danny.
Well, hello, everyone. First of all, thank you very much for joining this competition. I represent Project in Space, and I also wanted to thank SPE for the opportunity to collaborate in launching what we want to be not the first, well, it's the first, but we don't want it to be the last competition focused on AI innovation and targeting geothermal energy. Yeah, and this year we chose LLM workflows as spearhead in this kind of competition. And let me also say that we really want your feedback now and later on throughout the competition, because as I said, we want this to be the first of many. So all your feedback will be very welcome to organize events from now on. Yeah. You probably know SPE as being sort of the glue between subject matter experts in the oil and gas industry, but also between subject matters and, let's say, younger professionals. You may know a bit less about Project in Space. We're a non-profit association that tries to boost geothermal towards terawatts of energy. I invite you to join our website below to understand our mission and how we're trying to break barriers for geothermal. And the reason why we organized this contest, I just wanted to give you some background. Yeah, and I mean, for sure, this photo or this cartoon is a bit old. You can write LLM in there because it's definitely here to stay and to support all industries. And what we really were seeing is that, I mean, there's not that many movement on LLM and geothermal, and we wanted to make sure that the industry is not falling behind compared to other industries. So we were seeing this, let's say, ideas contest, this innovation competition, as a way to bring awareness about all the capabilities that LLM models and workflows can bring to geothermal, yeah, as part of our Pivot conference. And well, more information on that to come later on. Today, we're going to have a couple of presentations from Pratik and from Mike. I like to call them our keynote speakers. And when you see their photos, you will see that keynote and LLM, probably the average age of our keynotes is much lower than what you typically find in a conference, but that brings you an idea of how new these topics are and where the momentum and where the push to implement these models may come from. Yeah. So we'll have two presentations in order to give you some flavor of what's being already used in the oil and gas industry, easily translated into geothermal, but also what's coming from other industry, with the focus maybe more on chemistry, but with that broader view of what's going on in other industry, again, to inspire you how to find workflows for LLM workflows for geothermal. Yeah. We will continue with some rules of engagement, just going through our let's say, the rules of the game for this competition, and we allow some time for questions and answers. As Pradeep said, we also have the Slack channel for that, but that's also that we will comment on later on. Yeah. So without further ado, let's move on into our first presentation.
Yes, hello everyone. I'm honored to present to you Mr. Pratik Kumar. I got to know him and his passion from his two outstanding SPE articles He shared his profound insights about the applications of large language model in the oil and gas industry. His unique educational background, major in petroleum engineering and a minor in computer science, give him a competitive edge to leverage the latest advancements in artificial intelligence and intelligent automation in the energy domain. He currently works for Oil and Natural Gas Corporation in India and joined us for this kickoff meeting from Mumbai, India. So technology really shortened our distance. Without any further ado, I give you Mr. Kumar. Kartik, you want to share your slides?
Yeah, are my slides visible?
Yes.
Yeah. Good morning, everyone. As my son introduced, as she has given such a great introduction, I'm Pratik Kumar, and I'm presently here in Mumbai. It's night. Good morning to everyone. And I'm excited to start today's meeting, diving into a topic that stays at the very heart of the innovation in the whole field of AI, these LLMs. And today I'm going to basically give an overview how the LLMs are and of the transformative roles in the natural language processing in general. So earlier I was also having initially a slide in which I was about to introduce myself, but as she has introduced, I don't need to spend any time in the slide. So I would put you straight in the topic today's. So today's outline for this presentation is that initially, first we're going to see what are the large language models, and then second, what is the history of the language modeling, and third, in context learning, and the fourth one is what is prompt engineering, and then we're going to see what is the advanced prompt engineering strategies that you can apply, and then what are the issues that you have to also keep in mind when you're using with the LLMs in any kind of application. So one by one, we're going to go through everyone. So first is what is the large language models. So first for the large language models, is to understand what is a language model and how then it becomes large and additional L also comes. So a language model is basically a probability model which is going to assign a probability to each sequence of tokens. And we can say it's a probability distribution. It assigns a probability between 0 to 1 to every sequence token that is about to come. And the large language models assign a probability to every finite sequence. And I think that why these large language models has so much applicability in all of the fields and every industry. Yeah.
I think your audio is breaking. Can you adjust your headphone or anything a little bit better?
Yeah. Now it's better. Now the audio is now I'm adjusting. Now it's audible.
Yeah, it's better, I think. Thank you.
Yeah. So I would okay. So the people who not heard, I would like to go again. So first initially we're going to see what are the large language models. And for understanding of what are the large language models, initially we're going to see what is the language model basically. And so before that, I just said that a language model is basically a probability distribution over a sequence of tokens. In a language model, it basically assigns a probability 0 to 1, whichever token is provided. It may be grammatical, it may be a code, it may be a pixel also, it can be anything. If it provides a token to it, it gives a probability. That is basically a language model does. And the reason, and the large language models, and they're becoming so everywhere we see, and everyone is evaluating in every industry. We are also having this event workshop for application on the geothermal industry. Because of the large language models, the promise that it can give us a single model to solve many NLP tasks. And the reason why that isn't possible is because of the transformers architecture. The transformers architecture it was introduced in 2017, and since then it has become the standard default architecture in the whole field of the deep learning in the field of NLP. And if you see, this is just a backup slide I had. There is a brief history of the field of the whole field of NLP. If you see in the plot, we see that before the 2017, the default architecture which was majorly used in the solving the NLP problems was either RNNs or LSTMs. RNNs and LSTMs are other deep learning architectures, But in 2017, Google introduced a paper like attention is all you need. And they introduced an architecture, transformers. And since then, this architecture has become the default standard of the whole industry. So like I'm coming back to the again slide. Yeah. So the next slide is now why it is becoming the largest coming into the large language models. Just now I told that in 2017, Google introduced like their architecture transformers, and after that, every company or every model that was built like, that has a sort of a state-of-the-art performance is like more generally the transformers models. And since 2018 to 2020, we see that the number of the parameters of the model size that we generally refer it to, it is just going, becoming bigger and bigger. And the latest advantage, as everyone knows, is GPT. The GPT-3 model like, had 175 billion parameters. And GPT-4, they have not disclosed like how many parameters it has, but it will be definitely more than 175. And we see that with the due course of the time, every month these models are getting bigger, and everybody is pushing the limits of the SOTA performance that everybody has on many conventional NLP benchmark tasks. Now, the reason why I was saying the transformative architecture is the transformers. I am not going to do this, it's going to be very deep. So you can refer this paper, which I put it before. Attention is all you need for going to all the details. But basically, what it introduces a mechanism called self-attention. And this is the self-attention is the thing which has been like a major transformative role, or now applicable in almost to all of the data domains, within the vision domain, in the text domain, in the music, like in everywhere, the self-attention concept is a major defining one. And in the transformer architecture, basically they introduced two blocks, but one they call is encoder and another they call the decoder. And in their transformers, they use encoder and decoder both in the original paper. And the architectures that eventually came out from this paper were majorly three ones. One was a decoder, and then another was encoders, and another was encoder decoders. So the decoders is like everybody knows decoders, because the decoders are like they don't have any like bidirectional context. If you don't understand it, it's okay. You can go into detail. Just to have a brief idea, what is a decoder? So a decoder is basically the popular models that we use, GPT-2, GPT-3, Lambda models, and all these models are decoding models. And encoder models are the which were very popular in 2019, like when the Google introduced their BERT and Facebook introduced their Roberta. So at that time, the encoders were like very big thing. So and between there's third type of architecture, which also gives a very good performance in both, which is a best of the both of the worlds, encoders and decoders, encoder decoders. And the major popular the models that you know of the encoder decoder is a T5 and BART. And T5 and BART, T5 is also from Google. And now we come to the first part. Now we are heading to like what is the history of these large language models? These large language models are not a new thing in the industry. The first language model dates way back to Shannon in 1950s. The first language model was made by Shannon himself. And then the industry, like let's say mid 2000s, 10 to 15 years ago, the default language models that were used in the whole industry, it was a more of generally like, and the 3-gram, bigram models, like n-gram models were used. But since 2012, the deep learning took off. So deep learning was also applied into the field of NLP. So after 10 years, the new type of architectures, which have previously been talking about RNNs and LSTMs, they were like the major default architectures of deep learning. And they introduced a new thing also called transfer learning, which proved to be a very important point for the further developments. And in the last 3 years, since the OpenAI has released this ChatGPT, and before them, they first introduced the GPT-1 model. They have done another thing in the last 3 years, which have definitely changed, because they use a decoder and they have used also a very big model in data and models in compute. And the last 3 years have been simply a rise of another field. This is called prompting. We just simply prompt or instruct these large language models, and it does the task that we want them to do. So till now in the presentation, like I've covered the first and second points, like what are the language models, like why are they, and what is the history of the language modeling. Now I'm going to come to the third part, like this is the last 3 years development. Like third part, what is in-context learning? And in-context learning, the first time in context learning emerged was in the year of 2020. And 2020, like at the end of it, like when the GPT-2 came, the first time that OpenAI team was the first the company which was talking about in context learning, in the paper of GPT-2, they showed like the model is able to learn in context. It was basically an emergent behavior of these models, in which the model is not learning from the gradient steps, but the model is simply learning from the examples we provide in their context. So this was in the time of the GPT-2, if you see the paper, the initial observation that they gave, in the model was not that good. The model context learning was not that good. But by the time of GPT-3 in 2021 and GPT 3.5 in last year, ChatGPT, and now GPT-4, this in-context learning is becoming better and better. And in the paper, they also showed that in-context learning is basically like the model is not any time in the training has been trained to do a specific task, but in their context, if we give it examples like of addition or subtraction or language translation or any comparative task we do, it learns how to do it. It is going to imitate that behavior. And this was an emergent behavior, which was not seen in the field of AI before 2020. This was a new property that came with these large language models. Why they came, the theory that the OpenAI gave at that time is because of these models are becoming bigger and bigger, the models are showing there's some behaviors or some properties that were inherently they're not were trained off. And in context learning is like everybody now applies it. Like if you see like on all of the many NLP benchmarks, it achieves a SOTA performance. And many popular other models are there also by Google, like Lambda, and it also achieves a very good performance. And if you see in the Twitter, like everybody is posting something like it is able to write a code, it is able to design an app, it is able to generalize spreadsheet functions, but inherently it has never been pre-trained to do that. This is like the property of the in-context learning. Everybody is providing them a prompt in the information in the context, and the model is learning and it is generating an output. And then it comes to the field of prompt engineering. The prompt engineering is a relatively new discipline for developing and organizing prompts to efficiently use language models for a wide variety of applications and research topics. And a prompt can contain information like the instruction or question you are passing to the model, or include other details such as context inputs or examples. And if you see, if I'm going to zoom in, suppose this is a prompt that we provide to the model. It's a prompt we say where the sky is, and the model outputs. If you see the output blue, and then below the output, the sky is blue on a clear day. The model on a cloudy day, the sky may be gray or white. And if you read this, it doesn't make much sense because we have given the prompt to this model. Now, if we change the prompt, and if you if you give the instruction to the model, like complete the sentence, the sky is, the model output is going to be much better because the model is going to follow the instructions, and the tokens that it is going to generate are inherently going to have a much more probability. And if we now when we comment out what is the prompting strategies, like in our data analytics group in GC and like in which we work, most preferred techniques are like basically summarized into these four. And like you can include a couple of them more. Like this will be the default all of the strategies. First is like a zero shots prompting. Zero shot prompting is like when we give a model to do something without telling any examples, giving any demonstrations. This is like zero shot prompting. And zero shot prompting model is becoming very good. GPT-4 has like a very good zero shot prompting. Like you give it any prompt, it is going to give a very good answer. But then it comes to like few shot prompting, like in the previous models of GPT, like GPT-3, in which we have to give like a couple of examples. Like this is a couple of examples of addition or subtraction. Then the model learns from the examples that we provide in the context, so that the model is going to generate output. And the third thing with the concerns is chain of thought prompting. And this prompting was introduced by like in 2022 by the people at Google. So, and this is a technique that is very good. And this technique is like inherently presently used to solve the complex reasoning problems in let's say in the geothermal or in oil and gas. In oil and gas, most of the times you'll be using chain of thought prompting because you'll be doing a reasonable task. So you have to break your problem into chains so that the model is able to reason out. Model has the time to think. And see, like a chain of thought prompting, it's like an approach to solve multi-step reasoning problems by prompting. And the idea behind this is to model to produce a step-by-step solution of a problem can lead to more accurate answer. It was produced by B in 2022. And if we see the tool there in the paper, if the link below is given also the paper. In the paper, they show the two examples. In the left example, we see it's a question like a juggler test, juggle 16 balls, half of the ball at golf. It's a very simple answer for us with the basic mathematics. But the model is not able to understand, but the question and answer only. The answer is, if we say is, the model is generating 8. That is a wrong output. But in the show paper, they show this. If you raise the same question again, but in the answer, in the prompt you write, let's think step by step. The model is going to give its reasoning, and the model gives the right answer also. So in the paper, they show that if we ask the model to do step-by-step thinking, of like doing a chain of thought thinking, the model is going to inherently do a very good at reasoning task. And this was also showed by GPT-4 recently in their paper. In the recently paper of GPT-4, when they're introduced, they're shown like how they have like done like a very good sort of performance on the exams of the Stanford. They're shown like they've done a lot of chain of thought prompting. The last way prompting that is relatively new, that has just been observable just since GPT-4, is critique-based prompting. It's like basically inspired by like how humans think. It is like by offering constructive feedback on the LLM's initial response. The model is going to generate and improve its output, and it is going to fine-tune and is going to give us a much better response, and it is going to correct itself. And this is like a mostly, if you want to take it personally, I will say that this will be very useful when you're using it to code. Because if you're using it to code, the model is sometimes going to give a wrong answer. So if you just ask this, is it correct? Or hey, can you give us a better answer? It is going to go and reevaluate its response, and it's going to give again a response. And if that response is going to be wrong, it is going to acknowledge also. Like we have also done in like in terms of like solving the problem for reservoir calculations. If it calculates the reservoir like total oil in place wrong, but if you say it, are you calculating step by step? If you give us an exact critical response, then it's going to take that feedback and it's going to give us back and give us a good response. But this is relatively very new. This last prompt strategy is just 2 months old since GPT-4 came. And but while using also the LLMs, it's also to keep in mind what are the like issues with the LLMs. Like there are, this is like not for everything. The first very big issue is high cost and compute needs. It isn't, if you're thinking to, you're going to run LLMs on your own servers or like your own in-house organization servers, or like it's going to be very computable because the models are very large. And the second thing is hallucination challenges. If we see in the internet also in GPT-3, also ChatGPT also came, people are saying that it's gaining false informations. The model hallucinates also or not. The third concern is the privacy concerns. Well, because of these models are being trained on the whole internet data, it may also contain many sensitive data. So this also raises privacy issues. The fourth thing is pre-training biases. Because these models are inherently trained on initially the models were trained on a lot of Reddit data also, so a lot of social media data. So if you include those kind of data also into the training of these models, so the model is going to inherently learn from the Reddit responses and from the tweets. So the model is going to also have a biases because of the kind of the languages we use there. So the model also learns the pre-training biases. This also is a potential for toxicity, because we can ask them. People have shown like in Twitter, you can see a lot. The people say that we ask in order to generate a response that is not designed to respond, but it will respond. Like what are the reasons to make a bomb? And if you see in ChatGPT, Twitter, it was trending a lot. Somebody asked ChatGPT how to make a bomb, and it gave perfect response. So it also can be potential toxicity is also there. And so here comes I like cover all of them. And I was just thinking of giving an overview of large language models, and inherently that this is I presently think this is like this quote by the author C. Clark definitely describes the whole state of the field of NLP or AI in general at this moment, because it's like it is such an advanced technology, but it is like looking like a magic. So, but eventually, for a couple of years later, maybe everybody will be able to understand why the models are behaving the way they behaving, or why the models are learning, how the learning is actually happening. So these are the models like that will be implemented in the future. And like, if anybody wants to have like any detail about the architectures, I will have like backup slides about any type of architecture or any other laws or technique. So by this, like I would like I am finishing my presentation, and like any other query and any question, like I'm welcome.
Thank you, Pratik. I think we might want to ask you to maybe record your session also, because I think audio was very bad. So if you have some time later on, if you can record and we can share it with the participants again.
Okay.
But
Yeah.
unfortunately, we don't have a lot of time for questions, but you can put your questions in chat and Pratik can answer it in the chat. So feel free to put your questions in the chat. But now we will move on to the second part of the agenda, which is I'll let Danny introduce our next speaker. So go ahead, Danny. You're on mute.
Do you mind allowing me to share again? Somehow I'm not able anymore.
Yep, should be okay now.
Fantastic, thank you. All right, so we're moving on. I have the pleasure to present Mike Caldas. He's working as a postdoctoral associate in the University of Rochester, that I would say is one of the leading research institutes in the US, working with large language models and also spreading the word about large language models. They have coordinated together with Illinois and another Swiss university the first hackathon on LLM 3 months ago that has also inspired this competition, I may say. He has a background on chemical engineer. He's coming from Brazil. He has obtained his education from the University of Rio de Janeiro, UFRJ, where he was awarded one of the most prestigious awards, the Octavio Augusto Sebantunes, for academic excellence. And he's been a postdoc together with a group of Andrew White in University of Rochester for the last couple of years. So the floor is yours, Mike.
Thank you for the introduction, Danny, and thank everyone for the invitation. It's a pleasure to present to you all and talk a little about my work here in UFR. And I also would like to acknowledge, to thank Patrick Kumar, because most of the concepts that he talked, I will be like talking about here, like in a superficial way. So it was nice to have someone to actually describe in more deep details what I'm going to talk about here. My presentation is supposed to give a broad introduction and show capabilities of the model. So I'm going to show some of the models, some of the projects we have here in our lab. But before talking about any one of our own projects, I would like to point that out for the hackathon I participated 3 months ago that Danny spoken about. And I strongly suggest to go and scroll over the paper. It's a long paper. There are a lot of people involved, but there are really a lot of very interesting projects there. And it's a great place to have new ideas. And even though the authors in the paper described it 4 big areas, here in our lab, we are concentrating in those 2 first one, developing predictive models and tools and automation. So I will show some of the examples we have here for those 2. First of all, I will talk about tools and automations. People say that the large language models are supposed to be the perfect model to track all the possible challenges in NLP, in natural language processing. And that's true that the model has a lot of strengths. It can actually solve a lot of problems, a lot of general problems and common problems, but also the model has a lot of problems about updates, because since the model, in example, the GPT-4, it was trained with data only until 2022, so it's not updated. Any new information, the model has no way to access it. And also, they are well known for hallucination when the problem is too advanced or very domain specific. There's some ways to track that, but I wanted to propose an experiment here. Here in our lab, we went to ChatGPT and we asked it to multiply 2 large numbers, and it actually gave us an answer. It's a number, but by my mind, I cannot multiply those 2 numbers. But when we check it using a real calculator, we saw that GPT was off by 1 billion. And for some application, 1 billion is an error that is large enough and it's not acceptable. And how can we address that? The idea is, what if language models can use the calculator as a tool? So instead of trying to answer this question, when the model knows it has no knowledge about that specific domain, about that specific task, it has a tool available to use. And that's what is implemented in the chain of thought that Patrick just showed us. The idea is that instead of just completing a text, the model is supposed to, given the question you give to the model will reason and plan something about this question, search in the set of tools it has available, which tools it needs to use, then use those tools, and then make an observation. And based on the output of this tool, it will reason again and create a new plan. And then iteratively, it goes solving parts of your problem until you have a more robust answer to give you. And a tool is as simple as a function. It's a simple function. As we can see here, this is a simple Python function that I am defining the function and returning something. In this specific example, I am just using a solubility model. It's a deep neural network that we trained for predict solubility of molecules. And I could implement it as a tool for my model. And now the language model is able to use this tool when I ask it to compute solubility, because we know that predicting solubility is not one of the things that is in the domain of knowledge of the model. So one thing I would really want to stress here is that since they are language models, they are trained to deal with languages. So the way the model interacts with the tools is by reading the description you give about the tool. So those descriptions needs to be really descriptive, and you want to be as specific as possible. And you can play with that. There are a lot of suggestions on the internet. You can search for it and see what a good prompt is supposed to be. And now I will show two of the projects we have here in the lab using tools. The first one is ChemCrow. I wasn't directly working in this project, but I was following the development closely because I was really interested in this project. And what the authors did is they took a lot of different tools that usually we deal with in a daily basis as a computational chemist. So here's a not extensive list of all the tools the model has available. So we can search the literature, we can convert between names and different chemical representations for molecules. We can search for similar molecules, search for the price and commercial availability of these molecules. We have some synthetic tools to search for reactions, to predict reactions. A lot of other different ones that we use in a day-to-day basis as a chemist. And then we just showed it to the model and we started making some questions. One of those questions was about proposing new synthetic routes for some molecules. And by doing so, the authors, after having the suggested synthetic route, they showed to a specialist and asked the specialist to rank which answer was better, the one created by ChemCrow or the one created by GPT-4 without any tool. And what the human beings, the specialists evaluated was that GPT-4 could not suggest, could not propose reasonable reactions. Most of the reactions were even impossible or made no chemical sense, while ChemCrow came up with a lot of possibles, reasonables, and some of the specialists were positive that all those reactions routes were like possible to be implemented. So we could reduce the hallucination of the model just providing tools that we use day to day. So another project that I also worked with SAMCOS was the one we worked in the hackathon. Actually, we did a similar way, but we developed tools for materials. There's this data set called Materials Project that has an API to a lot of materials properties. And what we did was that we developed some tools to query this data set and ask for properties of materials. And it works fine, it's perfect. But the problem is, what if a material I am interested in is not available in this data set? So to make the model more robust, we use it in context learning. That is a specific prompting tool, a prompting strategy in which we, instead of taking the molecule, the material itself, because I know it's not available in the data set, then I take the most similar ones. I create a prompt showing some examples to the model, and then I ask the model to make a prediction now about the material that is not available. So since the model now could, between quotation marks, learn a little about my domain because I'm showing some context to the model, now it can make a better prediction. And we show that the model was working fine. And even though ChemCrow is not open source and available, MAPI LLM is open source. You can use it. Here we have a link to our GitHub repository. And also we have an interface implementation that you can just put your keys and make some questions. And please, if you need to give me if you want to give me some feedback, I will be glad to receive, and any suggestion of improvements too. Another thing is not focusing on tools now, but focusing on predictive models. Early this year, Dr. Jablonka showed that language models can learn chemistry by fine-tuning the models, and it can understand what a molecule is. So in this work, they showed that by fine-tuning the model, you can make the model carry out some tasks, some classification and regression tasks, and pretty good. The accuracy of the model was compatible with state-of-art models, and not only fine-tuning, but also using only in context learning. So now we don't even need to train the model. We can just show some examples and ask something, and the model is able to learn from this very specific and small context and give us some really good answers. But here they are tracking that they are using molecules representation. In our group, we thought on giving one step further, and we developed this model we called BO-Lift. And instead of using molecules, we thought, what if, because it's a language model, what if we can predict properties just passing an experimental procedure? Let's say we want to compute the property of a molecule. I just explain to the model how I synthesize that molecule, and then the molecule should be able to give me a prediction, right? Because a synthetic procedure produce a molecule, and this molecule has the information to compute the property. So what we are suggesting here is to bypass the molecule structure and predict properties directly from the experimental procedure. And here we are using also in context learning. Here we have the context that Patrick talked about. And by doing so, we could, of course, it was also showed by Dr. Jablonka, and we could develop really good models for predicting properties. But better than that, because the type of the prompt we developed, we could not only predict properties, but we could predict also with uncertainty. And because we had uncertainty, we could implement this model in a Bayesian optimization or algorithm. And now we show here that using GPT-4, we could even find the second better point in our set of possible examples. And this set had 12,000 points. So it's a huge search space, and we could find the second best one. And that's great. And even better, we were using only experimental procedure. Now, in this specific case, it was a synthetic a synthesis of a catalyst that we were interested to, but any problem that you can describe using English, using natural language, can now be optimized using BO-Lift. And also, it's great that BO-Lift is also open source. You can just go into our repository. There are some examples there. You can try to use it. And again, any feedback is more than welcome. As a last message, I would like to address some points here to have in mind when working with that, is that, yeah, we show that language models can be used for regression and for optimization. That's great. And even better, we don't need to mind about the molecule structure or the material structure, because we can just pass the procedure itself just using natural language. That's great. Also, your language model is always as good as your prompts are, even more in tools. By experience, I saw that depending on the description of the tools, the model behaves better or not. So spend some time thinking carefully on how to describe the tools, explain what is the input, what should be the output of your tool, and how the model can use that. You can also tell the model some priority between your tools using the descriptions. And we show that using tools is a great way of avoiding hallucination and some of the bad things language models does that Patrick also talked about in his presentation. And something I want to stress here is that this is a really fast moving field, and try to always be updated, not only on your project, but with the literature and the field as a whole, because most of the packages are not stable yet. People are developing it day to day, so it's possible that a update in one package breaks your project. So yeah, I would suggest you to pin a specific version of the library you're using, and after that, every week you try to update the package and check if everything's okay. It's really something you need to have in mind. Another thing is in our every project I showed here, we were using OpenAI API and GPT-4 as a base model. But in fact, there are some free models. They are not as good as GPT-4 yet, but I am positive that they will be in future. But I listed here some links that are like useful and definitely worth giving it a try. The first one is a repo that has a huge curated material about language models. They have the milestones papers that you should read to understand how the area developed and how the area is right now. They have a list of possible models to use, and even better, they have a list of free models to use with links directing to the page of the model or the paper itself. It's a really good repository. Also, we have the LangChain documentation. Oops, I'm sorry. We have the LangChain documentation. Every project here was developed using LangChain. And also here in the integration, they show which language models they support. Here is just a list of the most famous free access models. Llama 2 was just released. I still need to test it. I didn't, but definitely it's something I want to do. And yeah, just some names for you to have in mind when searching about that. And definitely go to Hugging Face. Hugging Face is a huge hub with a lot of models that the community open sourcely provide, and you can try to find something. They have also a lot of data sets that you can check and use. And lastly, I would like to thank you for the invitation and all the audience for the attention and the listen to me. Here, there are my social networks and my email if you want to get in touch, and the links for the project. Thank you very much, guys. I hope it was useful.
Fantastic, Mike. Thanks a lot. Pushpesh, do we have 1 minute maybe for a question from the audience?
Oh yeah, we have 2 minutes. Yep.
Yeah.
If there's any question, please feel free to ask. You can unmute yourself and ask a question or put it in the chat.
I actually have one myself, if I may break the ice, because I'm equally scared and amazed of the potential of combining LLM with the tools. Yeah, because it's no longer just we're writing text, it's you're giving them an opportunity and a toolbox to actually do things and do optimizations and do inventive ways of finding new molecules, new materials, and even new processes. So it resonates a lot, I believe, with what geothermal needs to do or can apply to go further from the current state of art. Maybe you can elaborate a bit more on the kind of chemicals that can be developed, because for geothermal, for example, you need oil field chemicals that can resist temperature and that can be effective at high temperature. Do you think there is a path there to do this kind of optimization if we provided a data set that I don't know, any company can work with? Yeah.
Yeah, definitely. In fact, I have some other slides here. I would like to show. It's nice for everyone to see. Focusing on the optimization itself, there is a technique called in the literature as LIFT, is the language interface fine tuning, in which you can have a data set that is just a tabular data set, and you can transcribe it in a paragraph, and then we can use this to optimize using languages. And the more important and more interesting thing is that we can implement our optimization as a tool, as yourself suggested. And by doing that, we can allow the model to explore the properties space and optimize the temperature and optimize which molecule you should use and anything like that. And that's really interesting because it's on language, and language, as I can think, is the most flexible possible kind of representation. So that's what I think is interesting.
Great. Thanks.
I saw that someone raised the hand.
Mike, I have a question maybe. So when we talk about fine tuning large language models, do you have any like recommendation of where we can find better ways or less hardware intensive ways to fine tune these models?
Yeah, definitely. As I told you, in all our projects, we were using OpenAI API. So yeah, it can have some cost involved, but we saw that when fine tuning, you can use the cheapest model. In this work, Jablonka showed that they fine tune using the most recent at the time was the GPT 3.5, the Da Vinci model, and also the cheapest one, and the results are almost the same. And if you train longer, the cheapest one, you have the same result as training the most expensive one. So if you are willing to use OpenAI, I would suggest you to just use the cheapest model and then fine tune for your specific task, like as a first try, and probably it will be enough. For the other models, yeah, the models usually are really large, and it's difficult to have an idea on the computational cost. And since we are using the OpenAI, I have no experience at all with training models locally. We and OpenAI deal with all of that for us. So yeah, I would suggest you give it a try on OpenAI, even though it have some cost initially. But once you fine tune your model and you're using the cheapest model, it's not that expensive to keep using it because it's the cheapest model possible. But yeah, I'm sorry, I don't have an idea on the computational cost for training those models.
Yeah, can I contribute to the answer like of this part?
Sure.
Yeah, I think in my mind, like if we are using like OpenAI, the only thing you have to always keep in mind, like what OpenAI going to do with your data. So always keep this thing in mind.
Yeah,
always
sure.
Because OpenAI, like OpenAI till now, the policy they have shown is they are not going to do anything with the prompts or the responses that we give, but they record all the data. But another source of answer which I want to give of the fine tuning, which you can do is if you want to fine tune, you can fine tune up to a Hugging Face of a model, say T5, up to a 10 or 10 billion parameter, or you go to smaller one like open source or GPT Neo, something 6 billion parameters that you can fine tune on your local PC. Fine tuning part I'm only talking about. But I'm saying like if your PC, like only local PC, I'm so talking about office PC, like it's like a very good memory, like that's something. But if you're talking about a personal laptop, if you're syncing, so that fine tuning is not going to be possible. But I will say try one thing, try parameter efficient fine tuning. There are techniques like LoRa. You can try LoRa. LoRa is going to be good, very good. LoRa we have tried. And another thing like which is very popular at this moment is trying adapters.
Oh yeah,
like
definitely.
Usage of adapters.
That Patrick told about
these are the two things that industry is using at this moment, because nobody can like every common people can't fine tune because it's going to be very cost intensive. And if you want to like use the open source model also, like of the OPT or like of the Facebook models also, or of the standpoint model also. So if you want to fine tune them on your own, like on a single laptop, so you have to do like adjustment to it. So you have to either use dual LoRa that's shown by Microsoft, can be done in a single laptop, or you can do adapters. You can use adapters. Adapters, in literature, I've seen people have used adapters till 4%. It works very fine. And I'm talking about the very models, like 75 billion parameters.
Thank you, Pratik. I think we have to move on to the next section. Sorry, we can answer questions on the chat. I'm so sorry. I think we're running out of time.
All right, so we move into the last section of this meeting, which is to describe the rules of engagement of our contest. All right. In order to answer the question of who, we're basically opening this to anybody, any team around the globe that has an enthusiasm for AI, particularly for LLM models and the potential that they may have to disrupt geothermal and help us accelerate research development, new products, new ways of doing things, new workflows. All right. So it's open to anybody, basically. All we're going to be asking for is to propose and demonstrate one workflow. Yeah. Contrary to what normally a datathon would imply, we do not have a data set. We're allowing you to play with whatever data set you want. And as Pratik said, please don't use your most confidential information. This is just more on highlighting an idea, highlighting a workflow where LLM can play a role, yeah, for geophysics, geology, whatever your discipline is. You're going to be able to work with your own data and propose a workflow. Basically, that's all we're asking for. And we will rank and give a prize, give an award to the best ideas. Yeah. Again, we're not asking for your code. We're only asking for a video around 2-3 minutes describing the problem, why you selected it, what kind of information you used, and just one visualization of how the code works. For the future, we do hope, just like Mike was showing with the GitHub repositories, this may be an idea that in the future we will evolve, but for the time being, we're just going to be as simple as it gets. We're just going to ask you for showing how the workflow is performing, and also considering the fact that, I mean, maybe the tools are not that stable these days, et cetera, et cetera. We don't really want the finalized product. We just want to rank ideas and with this, give visibility to the potential of LLM workflows, all right? We expect you not to spend any money on OpenAI, ChatGPT-4, et cetera, et cetera. We invite everybody to use open access pre-trained models, just like the ones that were listed by Mike. And you are allowed to use any one of them, no problem. And we are also, I mean, you have the opportunity to work on this contest on your own, or bring up friends, also talk to the people that are already in Slack, and try to make teams if you want, up to 4 members. Yeah, that would be the maximum that we would consider. Finally, from the perspective of legal boundaries, we don't want to claim any intellectual property over the things that you have generated. We don't want to, that's why we don't want you to share any code, just the visualization of what's going on. And by participating in this event, you're allowing us to mention your participation and appear in photos, videos, et cetera, but we will not make public any personal information. Yeah. And then again, as this is the first time we do this contest, just allow us to maybe change the rules as we go if we find anything that we may have not think of during the preparation of this event. Finally, let's not forget that we're giving a prize in cash for those that have the best ideas on how to implement a workflow, including LLM. I would say it's a quite generous one, yes. But we also have to acknowledge that certain locations around the world may have difficulties in receiving cash prizes. That's something that we'll have to deal with in a way that is satisfactory for everybody once we start seeing where people are joining from and who are bringing in the best ideas. Timeline. Basically, the people that are in Slack can start from now on, but we're still allowing others to join until the 1st of August. Yeah, we will give you an opportunity to work on your workflows and delivering them until the end of August. Yeah, we'll have a week to assess the solutions. We may have to have some sort of semifinals if we have a large crowd joining in and we have too many to actually visualize in the finals, because on the, it's on the 27th, inside of the Pivot conference, we will have an event where the finalists will be able to showcase the results. There will be a popular vote. There will be a technical committee. We will give the award, let's say, in a live broadcasting as part of the Pivot conference, which is a virtual event, by the way. You don't need to travel anywhere. And with this, I believe that's the rules of engagement, the time that we had allotted. I think I respected it. We still have some time left for questions and answers, so it's your time to maybe let us know what you think. If questions are arising, let us know. Okay, I see in the comments that Mike made a comment on BERT. Okay, so John is asking, can you elaborate on the allowable usage of the open source pre-trained LLM? You're for sure allowed to fine-tune anything. And in the end, it's just all about showing the potential of LLMs models. Yeah. So you can't just work with the pre-trained as is. You can add layers on it to enhance it. Yeah. And I hope I answered your question.
Yeah, can I also add like a couple of things?
Please.
Yeah. Yeah. If you like, there are a couple of works that are going for open source LLMs. One is like was done last year in 2021. It's a like when this model is called Bloom. It is done by like open like the guys from Hugging Face. Hugging Face has released an open source model Bloom. So it is like a parameter like till 176 billion. So it is possible if you want to train, like there are programs that are going on in which open source LLMs are built. Like currently, presently, there are a lot of programs that are going on in which the companies are building open source LLMs, and in which they are for the compute which they're using, going to do is they're going to use your laptops. So they're going to use your compute and they're going to integrate all of the, like they're trying to on that level. So that's how the people are doing it. Like so, but there are actually a couple of communities. If you enroll in them, just go and just enroll in them, and they just mails you and directly like ask you like if you want to like join it. So you can train models, but it's really very difficult because it's not just a base model. You can train a base model very easily, but after that you have to do instructions tuning also, and after that there is RLHF also. There are a lot of other processes also to get the final desired performance like GPT-4. So that's the thing. Base model people are doing, but other parts is.
It would be great maybe in the chat you put that information about Bloom or a reference for people to.
Okay, yeah. Great. Okay, so okay. Yeah, okay. I will figure out. Okay, yeah. Chat. Yeah, I will figure out. Yeah. Yeah. It's also open source model, and we also like try to use it, but it won't give you that much of a good performance. And our task it didn't give us, so we switched to that model. But it is available, and the best part is weights are also available, so anybody can download also. If you want to like have your own model, Bloom parameters are available. Weights and parameters, every parameter we have given. If anybody wants, like we can have the model also.
Thanks a lot, Pratik.
Yeah, and I also want to add some information that the Llama 2 is also now available, and the same way as Bloom, Llama 2 is open source. You can just use the weights. You just need to ask for the permission. You need to sign a requirement saying that you are not going to use it for a company if your company has more than 700 million users. And I think that it's a pretty much easy to not be in this case, but you can use it open sourcely and freely. And also it's available on Hugging Face. You can just search meta/llama2 and you'll have 7 billion until 70 billion models, parameters models, and you can also train from scratch or fine tune them.
Fantastic, Mike. Thanks a lot. Any more questions?
No, I think maybe we'll use one more minute to just talk about. We'll post all the presentation that you saw on Slack, and also I think all the team members are part of the Slack channel, so feel free to continue asking questions. I'm pretty sure this was an information overload, so you'll probably think about it and then come up with some questions later on. So just feel free to put it in Slack channel so we can answer live. And yeah, let us know what you think about, and if you have any other concerns, so we can address it. So with this, we are almost on time. If there is no other questions, we can close the meeting and we'll start publishing stuff on Slack. Okay, it seems like no other questions, so I'm gonna stop the recording. There you go. Thank you, Balnur. We just posted a link for the Slack channel on the chat, so you can find it. Okay, so with this, let me stop the recording, and thank you everybody for joining.